Section 7.2 is inverse trig functions continued. And again, it's nothing new. It's just taking what we learned in section 7.1 and then applying it to other types of problems. So we'll just jump right in. I got 1, 2, 3, 4, 5, 6, 7, 8, 9 problems in this section, and that's all we have scheduled to do today. So first example here, let's find the value. And we have cotangent of inverse cosine of square root 3 over 3. Okay, so the first thing we notice is we have two different trig expressions. We have a cotangent and we have a cosine. Okay, so what we did in the end of section 7.1, having a function and its inverse cancel each other out, that only applies if we have sine and inverse sine, cosine and inverse cosine, tangent and inverse tangent. Anytime we have different trig expressions here, so we have cotangent and cosine, they're never going to cancel each other out. So that actually saves us a little bit of work, knowing that whenever we have two different trig expressions, cotangent and cosine, they're never going to cancel each other out. So we don't even have to think about domains. We just proceed with this problem. Okay. The other thing here is we have these in opposite order than those problems we had at the end of section 7.1, meaning on section 7.1, those last three we did, we had the inverse function on the outside. Here we have the inverse function on the inside. So we're going to approach this a little bit differently. Okay, so here we have a composition of functions. Composition of function meaning two functions applied in a row. So first we have an inverse cosine function, and then we have a cotangent function, so two functions. In math, anytime we have more than one function or operation applied in a row, we always work from the inside out, right? Inside parentheses to the outside. So what I want to do here is start with the inside operation. We'll evaluate this, and then we'll do the outside operation. So inside operation, inverse cosine of root 3 over 3. This asks us to find the angle in our restriction for inverse cosine, which was 0 to pi, whose cosine is square root 3 over 3. Once we find that angle, our second step is to now find cotangent. Okay, so let's draw a picture. So our first step here, we want to find the angle in 0 to pi whose cosine is root 3 over 3. So drawing a picture, we want to find an angle in between 0 and pi whose cosine is root 3 over 3. We need to determine, first of all, should that angle be in quadrant 1 or quadrant 2? The way we determine what quadrant our angle is in is based on that value being positive or negative. So we're looking for the angle whose cosine is positive root 3 over 3. So if cosine is positive root 3 over 3, what quadrant should I put my angle in? Quadrant 1 or quadrant 2? Type it into chat there. Perfect. So cosine is positive. That happens in the first quadrant. Okay, we form a triangle. Here's our angle. We are told that cosine is root 3 over 3. So now we actually have numbers to work with. Those last problems at the end of section 7.1, we actually didn't know the lengths of the side. So this is a different type of problem. So cosine, we think SOHCAHTOA. So cosine is adjacent over hypotenuse. So now we can fill these in. So the adjacent side is root 3. The hypotenuse is 3. Now our question is to find cotangent. So SOHCAHTOA tells us tangent is opposite over adjacent, which means that cotangent is adjacent over opposite. So we're going to need to know this opposite side. So for the sake of time, anytime we have two sides of a triangle and we want to know the third side, we'll apply the Pythagorean theorem. I'm going to work this through one time for you on this first example, and then I'm not going to work through the Pythagorean theorem for you guys on the other examples. I assume you guys all know how to do it by this point. So remember the Pythagorean theorem, anytime we know two sides of the triangle, we want to find the third side. We know that a squared plus b squared is equal to c squared. The important thing is that a and b have to be the legs and c has to be the hypotenuse. Okay, so I have root 3 squared plus b squared is equal to 3 squared. Square root 3 squared is 3, plus b squared is equal to 9. Subtract the 3 from both sides, we get b squared is equal to 6. Take the square root of both sides, we get b is equal to square root 6. Remember, normally when we take the square root of both sides of the equation, we would put a plus or minus in front of it, but whenever we're doing Pythagorean theorem, because we're doing length here, we would just take the principal square root, which is the positive answer. So this side is square root 6. Okay, so we've done the inside operation, right? We found the angle in 0 to pi whose cosine is root 3 over 3. That's right here. Now we're asked to find cotangent of this angle theta that we found. So cotangent, we have SOHCAHTOA. So tangent's opposite over adjacent. That means that cotangent is adjacent over opposite, which is root 3 over root 6. Now remember, anytime we have a fraction as our answer here, we want to do three things. We want to first decide, should our final answer be positive or negative? Here we have an angle in the first quadrant, everything's positive. We also need to reduce our fractions and rationalize our denominator. Okay, so there's two ways of rationalizing this denominator. The first way is by multiplying both the numerator and the denominator by root 6. The other way of simplifying this is by recognizing that here we have a 3/6. That's going to reduce to 1/2. So anytime we have a square root over a square root, we can combine these into one fraction. So square root of 3/6. So the 3/6 reduces, of course, to 1/2. Now I'll split the square root up between the numerator and denominator again. So in the numerator, square root of 1 is 1. And in the denominator, I have root 2. We know from the last chapter, this becomes root 2 over 2. The other way you could have done this is at this step, multiply by root 6 over root 6. Your work would have looked a little bit different, but you still should have gotten the same answer. Any questions on this one? Any questions? Okay, 1, 2, 3, 4, 5, 6, 7, 8. I got 8 more. 1 down, 8 more to go. Okay, next one. Let's find the value of secant of inverse tangents of -2/3. Okay, so again, anytime we have a composition of functions, two functions applied in a row, we always start with the inside operation first. So the inside operation, we have an inverse tangent. So anytime we see inverse sine, inverse cosine, inverse tangent, we should think we need to find the angle. Where should this angle be? It needs to be in our restriction for tangent, which is -pi/2 to +pi/2. What do we know? We know whose tangent is -2/3. Once we find that angle, our second step is to find secant. Okay, so let's draw a picture. We want to find the angle for this inverse tangent. It has to be in quadrant 1 or quadrant 4. Has to be between -pi/2 and +pi/2. And we know that we want tangent to be -2/3. So if tangent is -2/3, in the chat box there, type in, tell me what quadrant should I draw my angle in, quadrant 1 or quadrant 4? Great, quadrant 4. Okay, so here's my angle in quadrant 4. Tangent is negative in the 4th quadrant. So we know that tangent is negative 2/3. So SOHCAHTOA tells us that's opposite over adjacent. By the Pythagorean theorem, which I'm not going to work through for you on all of these problems now, I assume you guys can all do that. We get that the third side is root 13. Okay, so we found the angle whose tangent is negative 2/3. The next step is to find secant of that angle. So secant is the reciprocal of cosine. So we think SOHCAHTOA, which means that secant is hypotenuse over adjacent. So hypotenuse is root 13. Adjacent is 3. Once we get our answer, 3 things we should ask ourselves. Should our answer be positive or negative? We're finding secant, which is the reciprocal of cosine in the 4th quadrant. So cosine in the 4th quadrant is positive, so it should be positive. Next thing, can we reduce this? No. Do we need to rationalize our denominator? No. So we're done. Any questions on this one? All right, let's do some more. Anybody need more time on this page? Okay. All right, next one. Let's find the value of cosine of inverse sine of negative 1/3. The other thing I'm going to try here is just to close my blinds. I'm not sure it's going to make a difference, but as you can see, our autofocus is kind of going in and out. So see if I can get this to focus in. Let me see if the lighting difference will help at all. Okay, so let's find the value of cosine of inverse sine of negative 1/3. Okay, so again, whenever we have composition of function, we always want to start with the inside operation first. So this inside operation says find the angle in our restriction for sine, which is negative pi over 2 to positive pi over 2. And what do we know about that angle? We know that sine is negative 1/3. Once we find that angle, the second step is going to be to find cosine of that angle. Okay, so let's draw a picture. We are asked to find the angle between negative pi over 2 and positive pi over 2, whose sine is negative 1/3. So we want to figure out what quadrant our angle should go in, and that's based on this value being positive or negative. So we're looking for the quadrant where sine is negative, so that is the 4th quadrant. This problem tells us sine is 1/3, so sine is opposite over hypotenuse. So here's our angle theta, opposite is 1, hypotenuse is 3. Next step, let's fill in our third side using the Pythagorean theorem. We get that this third side here is square root of 8. Okay, now we're asked to find cosine, so we think SOHCAHTOA. So cosine is adjacent over hypotenuse. So that's going to be root 8 over 3. Next thing we should do is look at our answer and ask ourselves those 2 questions. 1, should my answer be positive or negative? We're finding cosine of this angle. Cosine in the 4th quadrant is positive, so we're all set there. Next question, do we need to rationalize the denominator? No. And then our third question is, can we reduce, or I should add simplify the fraction in here? So we can't reduce, but we can simplify this. So here up in the numerator, we see a square root of 8. So we know that 8 is 4 times 2. So what we want to be on the lookout is perfect squares that we can simplify out of this radical. So 8 is 4 times 2. So this becomes square root 4 times square root 2 over 3. Square root 4 is 2, so this is 2 root 2 over 3. So that's the long way of simplifying. The shortcut way is by recognizing that there's a factor of 4 in here, and when we pull that out of the square root, that's where we get this 2 from. Okay, so our answer is 2 root 2 over 3. Now, or there's another method for answering this problem. Okay, so kind of the good thing and also the bad thing about math is that usually there's more than one way to approach a problem. All of these problems in this section, I like the graphical method, meaning drawing a picture. But the other way of solving this problem is algebraically. So algebraically meaning using formulas. So what we know, this part tells us we have some angle theta whose sine is -1/3, and we're asked to find cosine. So we know sine, we want to find cosine. The other way you could have solved this problem is by using the Pythagorean identity, sine squared plus cosine squared is equal to 1. If you like that, you're welcome to use it. But the one challenge of the Pythagorean identity is when you solve for cosine, you're going to end up with a plus or minus square root. And so you're still on your last step going to need to ask yourself, should it be positive or negative? And in order to evaluate that, you're going to have to figure out what quadrant this angle is in. So you're going to have to draw this picture anyway. I just want you to realize there's more than one way of doing this, especially if you were on a quiz or a test and you want to check both of those ways, you certainly can do it to make sure that your answers match. Now on the last two problems, I didn't mention the algebraic way of solving them, and that's because we actually don't have equations that relate those things to each other simply, right? The last problem was a secant and a tangent. We don't have an equation that relates those easily. Before that, we had a cotangent and cosine. We don't have a formula that relates those easily. So this one, because we have sine and cosine, Pythagorean identity, that's a pretty simple formula. You have that option. Any questions on this one? Okay, let's do some more. Next one, let's find the value of tangent of inverse sine of 4/5. Okay, so again, a composition of functions or order of operations. We normally start from the inside and work our way out. So let's start on inverse sine of 4/5. So this tells us to find the angle in between -pi/2 and +pi/2, whose sine is 4/5. Okay, so for inverse sine, we know our angle has to be in quadrant 1 or quadrant 4. The way we determine what quadrant the angle is in is based on this number being positive or negative. We're looking for an angle whose sine is positive. So sine is positive in the first quadrant. We are told that sine is 4/5, so we think SOHCAHTOA. Sine is opposite over hypotenuse. Using the Pythagorean theorem, or recognizing this triangle, we see that the third side is a 3. Okay, so we've talked about this, I think in the last chapter. A Pythagorean triple is 3 integers, meaning whole numbers that satisfy the Pythagorean theorem. 3 squared plus 4 squared is equal to 5 squared, right? 9 plus 16 is 25. This is a very common Pythagorean triple in our textbook and in geometry. These numbers work out really nicely. And we've seen a couple other ones that occur very frequently. So if you ever have 2 of these sides, you can use the fact that you know that 3, 4, 5 is the Pythagorean triple just to save yourself some work. The 3s and 4s have to be the legs, the 5 has to be the hypotenuse. All right, so we found the angle whose sine is 4/5. The next question on the outside is to find tangent. So we think SOHCAHTOA. Tangent is opposite over adjacent. So opposite here is 4, adjacent is 3. So our final answer is 4/3. We should ask ourselves 3 things. 1, positive or negative. We're in the first quadrant, so it's going to be positive. 2, can we reduce this? No. And again, make sure you leave it in fraction form. You do not need to write this as a mixed number, meaning you should leave it as 4/3, not as 1 1/3. And then third thing, do we need to rationalize the denominator? No, good to go. Any questions on this one? Okay, well, let's do another one. Looks like I need a new piece of paper. Let me give you a second here. Anybody need more time on this page? Next one, let's find the value of secant of inverse cosine of -√7/4. Find the value of secant of inverse cosine of -√7/4. Okay, so again, we want to start with the inside operation first. The inside operation is inverse cosine of -√7/4. Okay, so inverse cosine says, let's find an angle in between 0 and pi whose cosine is -√7/4. So if cosine is negative, that puts our angle in the second quadrant. We drop a perpendicular to the x-axis, forming a triangle, and then we'll fill in our sides. So this tells us that cosine is √7/4. So again, we think SOHCA TOA. So cosine is adjacent over hypotenuse. Using the Pythagorean theorem, we could find the third side, but before we do that, let's look at what this problem is asking us. This problem is asking us for secant. Secant's the reciprocal of cosine. So secant, we think SOHCA TOA. Secant is hypotenuse over adjacent. So on this problem, we actually don't need the third side of the triangle. So let's save ourselves that work. So secant is hypotenuse over adjacent. So that is 4/√7. Secant's the reciprocal of cosine, so secant should be negative. And then we need to ask ourselves three things. Can we reduce our fraction? Do we need to rationalize our denominator? And then secant in the second quadrant is negative. So those are the three things. I drew the picture here, but the algebraic method, if we had recognized right off the bat, this tells us cosine is -√7/4, find secant. So we know algebraically that if we know cosine and we want to find secant, all we have to do is flip the fraction, right? Take the reciprocal. Okay, so if you wanted to skip drawing this picture and just jump from here to here, you certainly could have done that using the fact that secant and cosine are reciprocals of each other. Okay, so we still need to rationalize our denominator, so let's multiply by √7/7. So we have -4√7/7 for our final answer. Any questions on this? Okay, let's do some more. Oops, I'm jumping ahead. So find the value of tangent of inverse cosine of -4/5. Okay, so again, we're starting with the inside operation first. So this inside operation says find an angle in our restriction for cosine, which is 0 to pi, whose cosine is -4/5. So let's start by drawing that picture. So if cosine is negative, that puts our angle in the second quadrant. Okay, drop a perpendicular, forming a triangle. We think SOHCA TOA. So cosine is adjacent over hypotenuse. Recognizing this as our common Pythagorean triple, or using the Pythagorean theorem, we get that the third side is 3. Okay, once we found this angle, now we're asked to find tangent. So we think SOHCAHTOA. Tangent is opposite over adjacent, so that's 3/4. Three things we should ask ourselves: can we reduce this? No. Do we need to rationalize? No. Should my final answer be positive or negative? So we're finding tangent of something that's in the second quadrant. Tangent in the second quadrant, all students. So that's an S, so this should be negative. The other way, of course, to figure out positive or negative is to track through these sides based on the X and the Y coordinates. Any questions on this? Okay, let's do a couple more. Okay, so let's find the value of cosine of inverse sine of 5/13. All right, so we see cosine and sine. So at this point, we have two options. We can either draw a picture, which is the method I prefer, and I find that most students like this as well, because you can kind of visualize things a little bit better. The other option is, we know what sine is, we're looking for cosine. We could use the Pythagorean identity and solve this algebraically as well. So you could do either way. Let's first start with the inside operation for sine in 5/13. That means our angle needs to go in the first quadrant. Drop a perpendicular, forming a triangle. All right, so sine is opposite over hypotenuse. So let's find the value of inverse cosine of sine of 5π/3. Okay, so this problem is different than all of the previous problems we did. The last 7 questions we did in a row, that inverse trig function was on the inside, right? We had inverse sine, inverse cosine, or inverse tangent on the inside operation. Okay, so this problem is different than the last 7. The difference is we have the inverse operation on the outside. All of the previous problems we did in section 7.2, that inverse operation was on the inside. Okay, so our method for evaluating this is still going to be the same. Anytime we have a composition of functions or something in parentheses, more than one operation, we always start on the inside first. So the inside says find sine of 5π/3. Okay, we know how to do this. So the inside will just find sine of 5π/3. So let's do it. 5π/3, that is 1 2/3 pi. So let's draw a picture. So 5π/3 is 1 pi plus 2/3 more. We are asked to find sine of this angle, so we know how to do this. We drop a perpendicular to the x-axis, forming a triangle. All the way around is 2 whole pi. So if this is 5/3, we ask ourselves how many thirds to get all the way to 2 pi. So you can either do 2 minus 5/3 or recognize that 2 is 6/3. So that means that this angle is π/3, which is of course 60 degrees. Now the spoiler alert on all these problems is we still only know how to do 2 triangles, right? That 45, 45, 90 and the 30, 60, 90. So anytime you actually have to come up with a value, it better be one of those 2 triangles. So we recognize this as a 30, 60, 90 triangle. We know our sides are 1, √3, and 2. Okay, so this inside asks us to find sine of 5π/3. So here's our picture. Sine of 5π/3, sine is opposite over hypotenuse, and sine in the 4th quadrant is negative. So I have inverse cosine of sine of 5π/3, we just figured out, opposite over hypotenuse, √3/2, and sine is negative. Okay, so this type of problem, we're starting on the inside just like before. We can actually evaluate it, come up with a value. What you want to do is just sine of 5 pi over 3. We just figured out that was negative root 3 over 2. We'll just fill that in. Our next step is to evaluate inverse cosine of negative root 3 over 2. Okay, so inverse cosine says find an angle. For inverse cosine, our angle has to be between 0 and pi, so either quadrant 1 or quadrant 2. We need to find the angle whose cosine is negative root 3 over 2. So if cosine is negative, that puts our angle in the second quadrant. Cosine is adjacent over hypotenuse. So here's adjacent, here's hypotenuse. Again, we only know 2 triangles. So when we actually have to come up with this answer, right, this is asking us for the angle, we will always get the 45, 45, 90 or the 30, 60, 90. We only know how to do those 2 by hand. So we should recognize this, or by Pythagorean theorem, you can get that the third side is 1. Okay, so this is a 30, 60, 90. The angle that's across from the 1 is the 30, or in terms of radians, that is pi over 6. Now be careful when we're not in the first quadrant. Our answer, we're asked what angle has cosine of negative root 3 over 2. That angle is the angle measured in standard position. This pi over 6 is our reference angle. So what angle is this green angle? That is 5 pi over 6. There's 2 ways of figuring this out. We know to 180 is 1 whole pi. So 1 pi minus 1/6 gives us 5/6. Or the other thing we can do is ask ourselves how many 6 plus 1/6 makes us all the way to 1 whole pi. If you prefer to do it in terms of degrees, of course, you could leave this as the 30, figure out this is 150 degrees, and then convert this to radians. Okay, so this type of problem is different than the previous 7 we did because we just evaluate every step as we go. Any questions on this? Okay, let's do one more of this type. Inverse sine of cosine of 3 pi over 4. Okay, so again here, we have the inverse function on the outside. So you don't have to really memorize when to do what, but just evaluate it step by step. So we always start on the inside operation first and then work to the outside. So on any of these problems, all you have to do to figure out where should you start is look at the inside operation first. So this inside operation asks us to find cosine of 3 pi over 4. So find cosine of 3 pi over 4. So let's draw a picture. 3/4 of the way to pi is right here. Drop a perpendicular to the x-axis, forming a triangle. If this is 3 pi over 4, that means that this angle is 1 pi over 4, right? 3/4 plus 1/4 gives us 1 whole pi, or pi minus 3/4 gives me 1/4. Pi over 4 is, of course, 45 degrees. So we know our sides are 1, 1, and root 2. So again, we only know these 2 triangles, 45, 45, 90, and a 30, 60, 90. So anytime you're asked to actually evaluate, come up with a number, you're going to end up with one of these 2 triangles. Okay, so here let's evaluate cosine of 3 pi over 4. So cosine is adjacent over hypotenuse, so that's 1 over root 2, and cosine in the second quadrant is negative. So cosine of 3 pi over 4 is negative 1 over root 2. Now at this point, we don't need to rationalize our denominator. This is kind of an intermediary, a middle step. Okay, so now we look at this whole operation. This asks us to find inverse sine of negative 1 over root 2. So inverse sine says find the angle in between negative pi over 2 and positive pi over 2, whose sine is negative 1 over root 2. So the first thing we need to do is determine what quadrant that angle goes in. The way we determine the quadrant is based on this value being positive or negative. So this value is negative, so we're looking for the quadrant where sine is negative. So sine is negative in the fourth quadrant. And this says to find the angle whose sine is negative 1 over root 2. So opposite over hypotenuse. And we should recognize this as a 45, 45, 90. Our answer is the angle measured in standard position here. Anytime we do inverse sine or inverse tangent and our angle is in the fourth quadrant, we're always measuring in the negative direction here. So our answer is negative 45, which in terms of radians is negative pi over 4.